Om Swastiastu. My name is Pamolango. I'm the student of University Udayana from the Mechanical Engineering program. At this time, I will present to you my metallurgy assignment that called Discovering Metals, a Historical Overview. The book source that I use is Metallurgy for the Non-Metallurgy second edition. The first one is native metals. Native metals were the only metals accessible to prehistoric humans, as the process of extracting metals from ore, smelting, is thought to have been invented around 6500 BC. However, they could only be found in relatively small quantities, so they could not be widely used. So, although copper and iron will know before the Copper Age and Iron Age, they will not have a great impact on mankind until the advent of technology that could smelt them from the ore. Thus, they could be mass-produced. Gold, silver, and copper are all examples of native metals that naturally occur in a relatively pure state. Ancient men first found and began using native metals approximately 5000 years BC. Over the next 2000 years, leading up to the Bronze Age, men mastered how to find, manipulate, and use these native metals in better ways and in range of application. The second is Bronze Age. Bronze Age began when it's discovered that mixture of two metals or alloy were stronger than either of metal taken individually. This discovery was probably made about the same time that extractive metallurgy was discovered. The discovery that tin alloy addition strengthened copper was the crux of the Bronze Age. A chemical analysis of the typical bronze alloy from the ancient Middle East shows that the alloy contained approximately 87% of copper, 10 to 11% tin, and small amount of iron, nickel, lead, arsenic, and antimony. It's less than 1%. From a technological viewpoint, accidental improvement in properties of metal is far different than the intentionally mixing of two or more ores or refined metals to obtain an alloy with the specific desired properties. However, by 3000 BC, ancient metallurgists had learned to intentionally mix ores of copper and tin to produce bronze that is very similar in composition to some modern alloys. The alloys that were made from intentionally mixed ores marked the real onset of the Bronze Age. The third is making metals extractive practice. Most metallic elements occur naturally as minerals or ores, which are compounds that result from a reaction between metallic and non-metallic atoms. Most copper, zinc, and lead ores are sulfide, while iron and aluminum are generally found in oxide ores. Extraction of metals from their respective ores requires work or energy to separate the metals from the sulfur or oxygen. The energy can be supplied in the form of heat, and the first extraction will probably accidental. Pyrometallurgy. Pyrometallurgy is extraction of metals from the ores by chemical reaction at high temperature in fuel-fired furnace. Pyrometallurgy may involve roasting and or smelting for the extraction or refinement of metals. Smelting. Smelting refers to melting process that separate metals in fused form from non-metallic materials. Hydrometallurgy. Hydrometallurgy is the leaching or removal of the metal from an ore body by passing a strongly acidic or alkaline solution over the ore. And the last one is electrometallurgy. Electrometallurgy involves the extraction of metals from their ore by the application of large of electrical energy. The fourth is iron. The first iron extracted from the naturally occurring iron oxide deposits could have resulted from primitive man building a woods or charcoal fire at the base of some windswept cliff. If the cliff outcropping happened to be rich in iron oxide, after days or even months of use, the fire cooled and the ashes contained a small amount of iron sponge. This sponge was the iron that remained after the oxygen had been removed. The iron had not been melted during its production. The sponge could be harmed into a shape and was relatively strong. Spear, arrow, tips, dagger, and other tools and weapons could be fabricated. The first iron to develop was rough iron. Rough iron can readily be forged to shape. In fact, the term rough means to shape by hammering or beating. Rough iron is very ductile for forging because it contains very little carbon, or less than 0.05%. Carbon is an interstitial impurity that strengthens the iron lattice. In fact, iron alloys that contain between approximately 0.1 and 2.0% of carbon have a special name that called steels. The fifth is discovery of modern metals. Beryllium. Beryllium is added to copper to improve its strength. The mechanism or process by which beryllium increases the strength of the copper is very different than the strengthening that results by tin or zinc addition to copper. Zinc addition to copper produces abrasives. Cadmium. Cadmium was discovered in 1817 and is primarily found in zinc ores. Cadmium coating or plantings were used to protect nuts, bolts, and other components made of high-strength steel or other relatively corrosion-prone metals. Chromium. Chromium was discovered in 1908 and is used mainly as a alloy addition in steel production. Chromium improves the resistance of steel to oxidation and corrosion and is an essential ingredient in stainless steel. Molybdenum. Molybdenum was discovered in 1781 and is primarily used as an alloy addition to steels. Because of its high melting temperature, molybdenum is used in the manufacture of high temperature heating elements and furnace trays. Tungsten. Tungsten was first refined from ore in 1783 and was originally called wolframium. The major use of tungsten today is the form of tungsten carbide, which is a very hard, wear-resistant material. Vanadium. Vanadium is among the hardest of all relative pure metals. Vanadium is primarily used as an alloy addition to steel for the manufacture of woodworking and metalworking tools. Magnesium. Magnesium is the lightest of widely used structural metals. Like many other metals, magnesium is rarely used for structure in its pure form, but becomes a useful structural material when alloyed with aluminum, magnesium, and zinc. Titanium. Titanium was discovered about 1790 because of its natural corrosion resistance. Titanium is also used in the chemical process industry and for orthopedic implants. Aluminium. Aluminium, the third most abundant element on the face of the earth, is a member of the family of metals that include gallium, indium, and thallium. Very pure aluminium like copper, gold, and silver is too soft to be much value as a structural materials. Iridium, rhodium, palladium, and platinum are, along with gold, termed the precious metals. They are all very dense and very corrosion resistant. However, the terms precious metals come from the fact that all these metals are expensive. And the last one is refining of metals. Refining of metals refers to process that purify extracted metals. Refining of metals, like the extraction of metal from ores, include many ancient practice and more modern advance. For example, gold always occurs in metallic state, and it can be extracted from minerals by relatively simple means. Refining technique for most metals are much more complicated, but it involves similar phenomena. Many techniques now used were not developed until the quite recent times. Today, refining can be used to produce very pure metals. That's all of my presentation today, and thank you.